Hello, in this video we are going to discuss about another page replacement algorithm. This page replacement algorithm is second chance page replacement algorithm. In this page replacement algorithm, we are using the concept of FIFO with some extra information, with some extra conditions. So as we have discussed in the earlier videos about the FIFO is nothing but first in first out page replacement algorithm. We have discussed the FIFO as well as we have solved some problem on the FIFO. Now it is the variant of second chance algorithm is a variant of FIFO algorithm. How that we will see in this video, and we will solve one of the problem. In this one, the reference string is given over here. These are the values in the reference string 2, 3, 2, 1 and so on. These are the values mentioned in the reference string. Now here we are solving this problem. Initially, the values which are kept up on these rectangles are the reference values which are going to be inserted into this memory. This memory is having 3 different frames, 1, 2 and 3, and we are having the maximum frames are 3 in here. So initially we want to bring the value 2 into the memory. So initially your memory is completely blank. That's why whenever you are swapping in the value into the memory, at that time there is a page fault. As we have already discussed in the earlier lectures or earlier videos, that if the memory is not having the values, at that time there is a page fault. So we have seen this thing in the page fault concept in the earlier video. So the memory is not having any values. Bringing the value 2 into the memory, we are getting first page fault, and I am putting this right mark that denotes there is a page fault. At the end we will count all these tick marks, which gives you the information that how many page fault occurred in this entire process. So 2 is added over here. In the second chance algorithm, we are using one extra information. That information is we are using some bit. That bit is 0 and 1. So this bit is 0 and 1. So if it is initially there, then we are using the bit 0. If it is a reference once more, then we are changing that value to 1. That we will see in the proceeding of this problem. After this 2, we are having the next value is 3. This 3 is going to be added into the memory. So initially there is a blank thing. So 3 is added and we are giving the value as reference bit as 0. And here there is a page fault. So there is a tick mark. After this one, we want to insert 2 value here. Already 2 is there present in the memory. So there will be no page fault. So your processor or your CPU is referring this 2 and continue its process. So there will not be any page fault. That's why 2 will be as it is over here, 3 will be as it is over here. There is no page fault, and the reference bit value is becoming 1, and here it is 0. Then we are going for the next value, which is 1, which is going to be inserted. We have to check it out, that is that 1 is there in the memory? No. So 2 is as it is, 3 is as it is with the reference bits 1 and 0, and there is a blank free slot or free partition where we are adding 1 over here, and this is a page fault and the reference value is 0. Later on 5 should be added, and in this one we have to check it out, that is there any free block, free slot? No, free frame is not there. That means we have to replace the existing value from the memory. Now the question is that which value has to be replaced, either 2, either 3 or 1, because right now we have said that this second chance algorithm is a variant of FIFO algorithm. What the FIFO says, that first in first out. In this one, if you look at the values, you will find that 2 came earliest, then 3, and the most recent is 1. So which value is there for the replacement? Actually, as per the FIFO, the value 2 is the oldest one, or it came at the first place, so 2 has to be replaced. But it's a variant of FIFO. So second chance algorithm is saying that if the reference bit value is 1, at that time we are not replacing this first ever came value from the memory. So we are giving a second chance to this value and going further for finding the next value. So 2 will be as it is, but the value of this reference bit 1 is becoming now 0. That is important. Actually 2 is a victim for the replacement, but the reference bit is 1. That's why 2 is not becoming the victim for the replacement, and 2 will be there in the memory, and the reference value from 1 it will be changed to 0. Then we are looking for the remaining values 3 and 1. In this one 3 is the oldest value compared to 1. So 3 is going to be replaced with the value 5, and 1 will be as it is. The value 5's reference bit is 0 and 1's reference bit value is 0 as it is, and there is a page fault over here. Now we are looking for 2. 2 is already there, so 2 will be there. Then the reference value will become 1. 5 and 1, the reference values are as it is. There is no page fault. Then we are looking for 4. While we are looking for 4, we are again using the oldest one, or the value which came at the first place will go out at the first. So 2 is the oldest one, but the reference bit is 1. So again 2 is not becoming the victim. So forget about 2. 2 will be as it is, and this 1 reference value will become 0. Then out of these two values 5 and 1, 5 came at this place but 1 came at this place. So who is the victim? 1 is the victim. So we are putting 4 over here, replacing value 1 with 4. Value reference value is 0 and 5 is as it is with this one. There is a page fault. Now looking for 5, 2 is as it is, 5 is already there, so it will become 1. There is a page hit. 4, 0, no page fault, because 5 is already in the memory. There is no need to bring the 5 from outside, from the backing store to the memory. So the value of 5 reference bit is changed from 0 to 1. Now we are looking for 3. So what are the values here? 2, 5, 4. Out of this one, which value has to be replaced? 2 is the oldest one, and the reference bit is also 0. Now 2 is replaced with 3 and the reference bit is 0. Rest of the values will be as it is. 5 and 4, 1 and 0 are the reference bit respectively. There is a page fault because we are replacing 2 with 3. Then looking for 2, 3 is as it is because it is the most recent one, and out of these two things, if you look at this one, 5 is the page which is from this place to this one and here, so out compared to the 4, but 5 has the reference value 1, so 5 will not get changed. 5 will be as it is, okay, and 4 is getting changed and its reference value is becoming 0, and 4 is changed with the 2 with the new value. There is a page fault. Then 3 is there, the value was 0, it is becoming 1. Then 5 with 0, 2 with 0, no page fault. 5 is coming, this is 3, 1, this 5 reference bit value is earlier 0, now there is a page hit, it will become 1, and 2